Welcome to BrewFix, where coffee meets craftsmanship. And one of the realities that both baristas and technicians eventually discover is that espresso machines rarely stay perfectly calibrated forever, because even the most expensive machines slowly drift out of spec over time as a result of heat cycles, mineral buildup, mechanical wear, and subtle changes in the internal systems that control pressure, temperature, and water flow. When a machine is new, it leaves the factory tuned within. Certain operating parameters such as pump pressure, brew temperature, flow rate, and valve timing. But these parameters exist within a delicate mechanical and thermal system that experiences constant stress every time the machine heats up, cools down, and pushes water through its internal components. And over hundreds or thousands of brewing cycles, those stresses gradually alter the behavior of parts that were once perfectly calibrated. One of the most common contributors to drift is thermal expansion and contraction, because espresso machines repeatedly heat metal components like boilers, group heads, and pipes to high temperatures and then allow them to cool again. And this constant expansion and contraction slowly changes how components fit together, affecting seals, gaskets, and fittings that maintain pressure stability within the system. Mineral scale from water chemistry is another major factor, since calcium and magnesium deposits accumulate inside boilers, valves, and narrow tubing over time, slightly restricting water flow and altering how heat transfers through the system, which means that the machine may begin delivering water at slightly different temperatures or pressures than it did when it was new. Pumps also change behavior as they age, particularly vibration pumps whose internal springs and valves gradually wear down, reducing their ability to generate stable brewing pressure, while rotary pumps may drift due to mechanical, where that changes how pressure is regulated. Valves and solenoids also experience gradual performance changes because the small internal seals responsible for controlling water flow harden or accumulate scale deposits that alter how quickly they open or close, subtly affecting the timing of pressure release and water distribution during brewing. Even temperature control systems such as thermostats, sensors, and PID controllers can drift slightly over time if scale buildup interferes with heat transfer or if sensors become less accurate due to environmental exposure inside the machine. These small shifts rarely cause immediate machine failure, but instead accumulate slowly until the espresso begins tasting slightly different. Shots run faster or slower than expected, pressure gauges behave differently, or the machine simply feels less consistent than it once did. And this is why professional cafés regularly recalibrate and service their machines to restore the original operating parameters. Understanding this concept of mechanical drift helps explain why espresso machines require periodic maintenance rather than being treated as static appliances, because they are complex systems where heat, pressure, water chemistry, and mechanical motion interact constantly. And over time, those interactions gradually shift the machine away from its original calibration, which means that maintaining great espresso is not only about dialing in grind size or recipe, but also about keeping the machine itself within proper operating specifications through cleaning, descaling, calibration, and preventative maintenance, something that experienced technicians understand well, and something we explore here at BrewFix to help coffee enthusiasts, baristas, cafe owners, and aspiring technicians understand how their machines evolve over time so they can maintain consistent performance and keep every shot of espresso as close as possible to the precision the machine was designed to deliver.